Hello chemistry students, today's video is on Lewis structures, and to greet you I have Mr. Gilbert Newton, most people just say GN, Mr. Gilbert Newton Lewis, the guy who's responsible for giving us Lewis structures. He didn't die until 1946, so he was alive before many of your parents, grandparents, he was alive, a contemporary with many of your parents and grandparents, so there's Mr. Lewis. Thank you, sir. Well, I'll put a smiley face next to his head. Thank you for what you've done for us. Lewis structures are one of my favorite topics because Lewis structures give us the shape, or are going to help us get the shape of the compounds. And why does shape or structure matter? You should remember from biology that, well, that's not how you spell structure. Structure determines function. I change it to structure determines behavior. And so Lewis structures that we're starting today will help us know the structure, the shape of a molecule, and that will help us predict its behavior, which is cool because in chemistry that's what we want to do. We want to predict what's going to happen before we do it, or we want to explain particular behaviors. Nice. Thank you, sir. Goodbye. Did you catch that? Goodbye. All right. These are the super magic steps for drawing a Lewis structure. What I would recommend you do right now is pause the video. Yes, you can pause. Isn't that great? Pause the video and write these steps down. Okay, hopefully you paused and wrote. If you didn't, you're not going to be able to keep up because I'm moving on to lots of examples. And so now I'm going to do about, I don't know, 10, 20, 30, 40 million Lewis structures. And so you can see all kinds of different examples, and I'm going to point out all the different mistakes students make, and I'm going to point out how to make 100 on your first Lewis structure quiz. Okay, so the first Lewis structure I want to do is carbon tetrachloride. Carbon tetrachloride. Now, I guess I should have said this at the beginning. Lewis structures show us the behavior, or show us how elements combine covalently. So Lewis structures are all covalent stuff. This is how elements combine to make molecules. Whoo, I didn't mean to do that. It's where elements combine to make molecules, how they share electrons. Remember, covalent means sharing electrons. So this is not going to apply to ionic compounds, but anything that forms a molecule, anything that bonds covalently, you can draw a Lewis structure for. Our first one is going to be carbon tetrachloride. First thing you'll have to do is you'll have to know the formula. Carbon tetrachloride is CCl4 because tetra means 4. Carbon doesn't have a prefix. Whoops, I moved the recording window, not what I meant to. Since carbon doesn't have a prefix, that means mono. All right, now we need to add up valence electrons. A lot of students confuse this with charge because we worked with ionic compounds and we did charge after charge after charge after charge. Now we've got to write down the total number of valence electrons. Carbon is in group 14, so it has 4. Chlorine is in group 17, so it has 7. But there are 4 chlorines here, so we're going to do times 4. So, and I'm going to put a plus in the middle. So 4 plus 7 times 4 equals 32. 32 is the maximum number. Write yourself a helpful hint. Helpful hint. 32 is the maximum number of valence electrons you can have. Well, in our class. 32 is the maximum number of valence electrons you can have in our class. Okay, so now we're going to move on to step 2. We're going to figure out who goes in the center. In most cases, you can look at the elements. If you have 4 of this and 1 of this, then you're probably going to put the thing that you only have, the element you only have 1 of in the center. So I'm going to put C in the center, and I'm going to connect it. I'm going to put 4 Cl's around it, and I'm going to connect them with single bonds. This line, this line, this line, and this line each indicate a single bond, which is a pair of shared electrons. One pair of electrons. So every time I draw a line, that's 2 electrons. Each bond is 2 electrons, a pair. So how many electrons are on my drawing so far? This line represents 2, this represents 2, this represents 2, and this represents 2. Okay, sorry, had a minor interruption. So how many electrons is that? There's 2 here, 2 here, 2 here, 2 here. That makes 8 total electrons. So I have 8 electrons in my drawing so far. So careful when you're doing Lewis structures to note that the line represents 2 electrons. And then the next step says make everybody else stable. How does everybody become stable? They all need 8 total electrons. So this chlorine already has 2 because there's a bond here. It needs 6 more. So I'm going to give it 2 here, 2 here, and 2 here. That gives this chlorine 8 electrons. 2, 4, 6, and this line counts for 2, so that's 8. Then I'm going to give this chlorine 8 valence electrons total. 2, 4, 6, 8. And then this chlorine gets 6 more, and this chlorine gets 6 more. Is it always this easy? No. No, child. All right, now I've made everybody. Oh, I didn't make carbon stable. Let's make carbon stable. How many electrons does carbon need to have around it? 8. How many does it have? Well, 2 here. That line is 2, that line is 2, and that line is 2. So carbon has 8 valence electrons. It's stable as well. So remember that the line, the 2 electrons here, can go with either element, with the chlorine or with the carbon. So when we're counting up, we're going to let that line go to both. Good? Good. Now the last step is to count my total electrons. How many total electrons are in my drawing? I'm going to count those in purple. So we have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32. I have 32 total electrons in my drawing. I'm going to backspace all of those circles now. 32 electrons. Now how many electrons did I calculate I needed earlier? I calculated 32. When the total number of electrons equals the number you're supposed to have, you are done. Check, you are done. Now careful there, okay? Careful, careful, careful. Remember that you're going to make everybody stable. What's the magic number of electrons? Is the magic number of electrons 8? Yes, it is. Okay, let's go to another example. We'll just stick with purple. Okay, so the next example we're going to do is going to be water. If you hear strange sounds in the background, Teresa is in the storage closet making up a quiz. Teresa, say hi to my classes.
Hi, guys.
Okay. All right, so H2O, so we need to figure out how many valence electrons that has. Hydrogen has 1 valence electron, and oxygen has 6. But there are 2 hydrogens, so we're going to multiply that by 2. And on water, we get a total of 8 valence electrons. So then what do we do next? Step 2 says put an element in the center. In this case, it's obvious that oxygen goes in the center, but just for future reference, hydrogen can never be the central atom. Hydrogen can never be the central atom because hydrogen can only form 1 bond. So don't ever put hydrogen in the center. So we're going to put oxygen in the middle, and then we're going to connect 1 hydrogen and a second hydrogen. And now our next step is to make everybody stable. So this hydrogen is stable because it already has 2 electrons. Hydrogen only needs 2 electrons to be stable. So that hydrogen is good. This hydrogen is stable because it has 2 electrons right there. That hydrogen is good. We don't need to do anything with that. Never put dots on a hydrogen. Never put dots on a hydrogen. All right, now oxygen, though, in the middle is not stable. Oxygen has 2 electrons here and 2 electrons here. That makes 4. How many more does it need? What is 8 minus 4? 4. So we're going to put 2 here and 2 here. And now oxygen is stable because oxygen now has 8 valence electrons. And then we're going to count our total electrons. I have 2, 4, 6, 8. I have 8 total electrons in this drawing. How many electrons am I supposed to have in this drawing? Go all the way up here. I'm supposed to have 8. Yippee! That's correct! Yay! The crowd goes wild. I'm very self-conscious with Teresa listening to me make this video. Alright, so let's do another example. Let's make it up off the top of my head. Okay, so this example is going to be carbon. We're going to do carbon monoxide, CO. Carbon monoxide is the first one that's going to have multiple bonds in it. It's going to have more than single bonds between elements. So watch this guy. This guy is lots of fun. It's very popular overseas. People love to do Lewis structure for carbon monoxide. Carbon is in group 14, so it's 4 valence electrons. Oxygen is group 16, so it's 6 valence electrons. That is a total of 10 valence electrons we have to finish with in our drawing. So then who are we gonna put in the center? C or O? Doesn't matter. There's only two elements. There's really technically not a center. So I'm just gonna hook C to O. That's the way I like to do carbon monoxide. And then I'm gonna make everybody stable. How am I gonna do that? Well, carbon has 2 electrons, and then I'm gonna add 6 more. So carbon has a total of 8. And then oxygen has 2 electrons, so I'm gonna add 6 more for a total of 8. And then I'm gonna look at this. I'm gonna go, hey, how many electrons do I have in my drawing? Let's count them. Let's count them. 2, 4, 6, 8, 10, 12, 14. Did you count 14 with me? Is 14 the right number? Is 14 too many? 14 is way too many. I was only supposed to have 10. So this is a situation where I've got to add a double bond. So here's how you do it. You add a bond. Did you see the bond? And now you have to take a pair of electrons off of each element that bond connects. So I have to take a pair of electrons off this oxygen and a pair of electrons off that carbon. Is that hard to remember? No. But let's say you forgot that I said take a pair off each element it connects. Let's count how many electrons are around oxygen right now. Now that I added that double bond, that's 2 electrons, 4 electrons, 6, 8, 10. Well, 10 is too many. Everybody needs how many to be stable? 8 is correct. Did you talk to your computer? I hope you did. All right. So now each element has 8, and I added a bond. Now I'm going to count my total electrons again. 2, 4, 6, 8, 10, 12. Are you freaking out? Oh my gosh. I have 12, but I'm supposed to have 10. What do you do when you have too many? You add a bond. When you have too many, you add a bond. When you have too many, you add a bond. What if you have too few? That means you messed up. So I'm going to add another bond. When you add a bond, what do? You take a pair off of each side. Does it matter which pair you take? Not really. Okay, so now I'm going to check to see how many valence electrons this carbon has. 2, 4, 6, 8. That carbon has 8 valence electrons. That's good. So that carbon is stable. Let's check oxygen. 2, 4, 6, 8. That oxygen is stable. That's 8 valence electrons. I'm happy with that. Now let's count the total number of electrons. 2, 4, 6, 8, 10. See? Now I have 10 electrons in my drawing, and I'm supposed to have 10 electrons in my... Okay, example number 4. I think we have time for 2 more examples. I'm going to speed up a little bit so we can get 2 more examples in here. Let's do sulfur dioxide, SO2. Sulfur dioxide. So sulfur has 6 valence electrons, and oxygen has 6. There are 2 oxygens there, so I'm going to multiply the oxygen by 2. That's going to give me 18 valence electrons I need in my drawing. So then I'm going to put S in the middle and O on the outside. On this one, how do you know that S goes in the middle? Well, let's just look. There's only one S and there's 2 O's, so that's logical. And then we're going to make everybody stable. I'm not counting electrons right now. I'm just making sure every element has 8 valence electrons. Every element has 8. Cool. Did I just hear the bell ringing? Okay, so since now everybody's stable, I'm going to count my total electrons. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Right now I have 20 electrons, and I'm supposed to only have 18. So what do? What do you do when you have too many electrons? That's the rule where you add a bond. So which side do you add to? Doesn't matter. Pick your side. I'm going to add a bond right here. And then I'm going to take a pair off of that one and a pair off of that one. And as I count, 2, 4, 6, 8, 10, 12, 14, 16, 18. Now I have 18 electrons. And check, it's done because I wanted 18. Last example is going to have to be fast. So you're going to see that I'm going to pause. Okay, you can also do a Lewis structure for polyatomic ion. So I have 5 for nitrogen. 6 oxygen times 3, but the -1, remember, means took 1, so we're going to add 1 to the total, so I'm going to put +1 at the end. So how many electrons do I have in my drawing? 18, 20, 24 electrons. And now I'm going to put N in the middle. I only have a little bit of time, so I'm going to pause and show you. Okay, so you just saw the video jump as I filled in all of the valence electrons, and I counted, and I have too many. So I'm going to add a double bond. So I only have 9 seconds. So you see I added a double bond, took two pairs off and added a bracket with the charge. That's the end.